Alright, hi you guys. Today we'll be talking about, in Algebra 2b, we'll be talking about binomial distribution. So first off, the binomial experiment. Binomial experiment is when there are a fixed number of trials, and each trial has two possible outcomes, and the trials are independent, and the probability of each outcome is constant throughout the trials. Okay? Alright, and here's the formula on this one. So the probability of x is equal to NCR times p to the x times q to the n minus x. Okay, a lot of confusing stuff in there, but I'll explain each one in a step. Okay, so NCR is just the combination, so it's NCR. So N is what you'll be given, and R is listed right here, and I'll explain where these numbers are coming into play. Okay. Alright, so the probability of success is going to need to be defined, or the probability of failure. Why? Because the probability of success plus the probability of failure must equal 1. So for probability of failure, all I need to do is go 1 minus the probability of success, or to get the probability of success, I need to go 1 minus the probability of failure. Okay, so let's say a baseball player who's batting .300 over lifetime. He goes through the next 15 at-bats. Okay, let's say that his success rate of getting a hit is 0.3 or 30%, or he's batting .300, so therefore his failure rate is 700%. Okay, and let's say, what's the probability of him getting 6 hits in his next 15 at-bats that this is known? Okay, so what we do is we just set it up. So the probability of getting 6 in the next 15 at-bats is, we put in our calculator, we go NCR, and then we go, what is it, 15, choose 6, okay, and then you're going to times that by, okay, the first one, which is going to be 0.3, and you're going to raise that to the 6th power, okay. And then you're going to times that by the 0.7, and you're going to raise that to the n minus x, so that's going to be the 9th power. Okay, and we do our calculation on here, so let's go NCR 15, choose 6, then we times that by 0.3 raised to the 6th power, and then we times that by 0.7 raised to the 9th power. Okay. Alright, and the chances of him getting 6 hits in the next 15 at-bats is 14.723%. And it's really kind of cool how you can actually do that. Okay. Now, the binomial theorem is just like binomial probability, except with binomials in algebra. Okay, because if you remember, we talked about it. Pascal's triangle is like combinations. Okay, so if we're raising something to the nth power, we just do the first number, which we all know this is going to be 1. And the first term, and I like to think of this as, okay, this one starts at the highest and the powers go to the lowest, and then B starts at the lowest and goes to the highest by the end. So a to the n minus 1, a to the n minus 2, all the way down to a to the 1, a to the 0. So it goes down to the lowest. And then B is going to start at the lowest, whatever B is, you're going to raise it to the 0 power, which will be 1. Then you raise it to the first power, then second power, and then to the n minus 1, and then finally to the highest power possible, which is to the n power. Okay, so I like to think about it that way. Now these numbers in front are, you can actually find these in the Pascal's triangle if you use it, or you can just go ahead and punch them in and you're able to find out the numbers as you go along. Okay, alright, so for example, if we did 2x plus 4, let's raise that to the 5th power. Okay, so you could quickly write this out as NC0 times, well, it actually would be 5 choose 0 times the first term to the 5th power, so it would be 2x to the 5th, and you're going to raise the whole thing to the 5th power, and then times what is that, 4 to the 0. Okay, then you're going to add that with 5 choose 1. Okay, and you're going to times that by 2x to the, oops, once again you're raising the whole thing to the 4th power, and then you're going to times that by 4 to the 1st because you're increasing. Okay, and I'll fast forward so you can see. Okay, so now my formula is all set up to look like this, and when I start doing my calculations and working this out, okay, I can actually rewrite it like this, which is going to look like something like this when I get done simplifying all the combinations and then raising to the powers and everything. Okay, and then I'm going to show you what the shortened version is going to be when I simplify everything. Okay, and so it's going to look like this: 32x to the 5th plus 320x to the 4th plus 1280x to the 3rd plus 2560x to the 2nd plus 2560 to the x, or times x, plus 1024. Okay, and that's how you do binomial theorem stuff. And it's a lot of fun. It's a lot of fun to work with, and you can actually use Pascal's triangle to get those numbers a lot faster. Or you can just basically plug in everything as is and be able to actually do it and simplify it. The only issue I see a lot of people having with is forgetting to raise to 2 to the 5th power as well here, raising 2 to the 4th power here, raising 2 to the 3rd power here, 2 to the 2nd power here. This doesn't matter as much, and this definitely is just going to turn into 1. Okay, but a lot of people forget to do that and they screw up on these ones. Okay, alright, that's it for binomial distributions. Just make sure you take your time when you're doing your calculations, find your probability of success and your probability of failure, and work with it that way. Okay, thank you. Have a great day. Bye.